Paul, we did have one question that came in. Can you tell us what the accuracy is of the HOBO conductivity logger?
Yeah. Actually, in case anybody was interested in a little bit more details on the HOBO conductivity logger, I have a slide here. Let me see if I can go to it. Well, it looks like let me try this. There it is. Sorry about that. If you look at, there's a couple of ranges. There's two ranges on the conductivity logger, the HOBO conductivity logger. One's up to 1,000 microsiemens per centimeter, and one's up to 10,000 microsiemens per centimeter. And the accuracy is 3% for 5, I've pointed here, or 5 microsiemens per centimeter, whichever is larger. So if you're down in the very low conductivity range, let's say you're down in kind of a glacial runoff stream, you're down below 100 microsiemens per centimeter, then the 5 microsiemens per centimeter spec is going to be what applies. For larger conductivity measurements, that 3% spec is what's going to apply.
I have another question. How often does the U24 need to be recalibrated in the field?
So basically, that's going to be dictated by the amount of following that's out at the site. You'll basically, every time you want to go out to the field, I would take another calibration reading and then compare that to the actual measured data that you get from the logger. So you can bring in the raw data, the raw conductivity data, and then compare that to your calibrated readings, and that'll give you a sense for how much sensor drift and how much following is affecting your measurements over time. If it's a fairly clean environment, you can stretch out the duration between having to go out and take calibration readings for your logger. If it's kind of a harsher site and you're finding that your measurements are changing fairly quickly, then you'll want to go out and take calibration readings more frequently. I would typically go out at least a month, though. It's just kind of a rule of thumb for starting out. Go out every month and take calibration readings.
I have another question.
This is a good question. Can you talk a little bit about how non-contact sensors work? Basically, there's a couple of different technologies for doing it, but basically they measure capacitance, and the capacitance changes with the conductivity of the water. So that's how it's able to detect changes in the conductivity of the water. There's toroidal sensors which use coils and to detect the changes in capacitance due to the conductivity changes. Ours actually uses a couple of probes within the sensor, so it's not a toroidal approach. It's kind of a fairly unique approach, but basically it's a capacitive approach for measuring the changes in conductivity. Let's see.
No. Well, it looks like there aren't any more questions. So this concludes today's webinar, and thank you for joining us. If you would like additional information, you can contact us at 1-800-564-4377, or you can email us at sales@onsetconf.com or visit us on the web at onsetconf.com. Thank you for joining us today.